Hello 6B, we are looking at multiples and factors. From multiples and factors we're going to move on to prime composite numbers, square numbers, and then into order of operations, which is the BODMAS. First, look at our learning intention. We are learning to use a chart to help locate multiples and factors. So it's a bit like a times table chart can actually help locate. Hopefully someone has. Yes, they have. Here we have. So these charts here, along the top, across the top, we've got a multiplication in that corner. And we've got 1, 2, 3, all the way across until 12. Going down, it's the same situation. So the whole point of this, if we went, I wanted to know what 3 times 3 is. I've got 3 here, and I go across. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. So my multiples, I can learn them that way. Multiples of 4. My first multiple of 4 would be 4, because 4 times 1. Second multiple of 4 would be 8, because 4 times 2. 4 times 3. And what I'm actually doing here, if I wanted to know what 5 times 5 is, which we all know is 25, I get the 5 here, and I go across, and I've got the 5 up here, and I come down until they meet, and they would meet right here, 25. So the multiples of 5 would be 5, 10, 15, 20, 25, 30, and so on. Multiples of 5 will always end in either 5 or 0. 5 or 0. 5 or 0. Okay, there's all these little tricks to help you. Now, if I wanted to do it the other way, if I wanted to find factors of maybe 20, so I found a 20 here, and I know if I go across here, 5 runs into 20. If I go straight up, 4. So 4 and 5 are a factor of 20, I should say, because 5 times 4 is 20. Have a go at using this, but the whole point is to actually understand the difference between multiples and factors, because I know in the past people can get them mixed up. And one way we might remember is in our alphabet, F comes before M. So multiple sounds like multiplying, it's getting bigger, multiplying. Factors fit in. Okay, so factors fit into a number. So F comes before M. So F, maybe think of as the smaller one. M is a bit bigger, further down the alphabet. So maybe think of it that way if you get a little bit confused. So what we're going to do, I've got it up on the board here. I want you to copy this neatly in the book after you've written your learning intention. Use a chart to help locate multiples and factors. You can use a chart. If you're able to not use a chart, then go with that. So let's look at this first one. Multiples of 2. So you always have to put the next one in. So multiples are getting bigger. So my first one would be 2. 2 is a multiple of 2 because 2 times 1. Next one would be 4 because 2 times 2 equals 4. 2 times 3 would be 6. So these are the multiples. What would be the next 2? I think you could do all these. I'll go to the 5s because I know we've just sort of done that. So the multiples of 5, first multiple, it's 5 times 1 would be 5. 5 times 2 would be 10. And here you can see the last digit, or the digits are always going to end in 5 or 0 when it's your 5 times table or your multiples of 5. Next one would be 15. What do you reckon the next one would be? And so on. Okay, so that's what I'm going to get you to do. Neatly do one. So A, B, C, it doesn't matter which order you do them, as long as we clearly know. You've got that 5, there's a comma. You could actually put the 5, this is what you're trying to find the multiples of. You could have 5, you could do that if you like. It might even be easier, because I guess this one has actually got that comma in there, which means that would be your first one. So I would do this, just put there. So the next one, next multiple would be, first multiple of 11 would be 11. Okay, so put these in there and we'll go from there. From there, let's do 10 times. And what are the multiples of 10? Here's my First one would be 10, 10 times 1. Next one would be 20, times 10. Next one, 30. Have I? Tell me if I've missed a couple. Correct, correct, correct. What we're going here? 40 and 50. 60, yep. 75, I've got to put 70. 75? No. That's a multiple of 5. So these ones are not going to work. If I come down a little bit further, actually I'll bring this board up. So you complete these, A to G. Now, have a go at this one here. Question 2A. Which of these following multiples are multiples of 3? Multiple of 3, so 3 times table is 18. So then you sort of go, well, something times something could be 18. 2 times 9. 2 times 9 works, but it's not 3. So you have to go your 3 times table. 3, 6, 9, so on. And I'll give you a hint. 18 is. Yes, 18 is. I can actually look at this and I can see there's possibly 4 that do not belong in here. Possibly 4. Okay? And then we'll just pause it there. From here, I'm actually going to get you to go back and I'm going to take a screenshot of this, so this will be underneath this video or above the video on Google Glass. If I come up here, then we've got the opposite to multiples, which are factors. So I'm just making sure we can see this. Find the factors of each set of numbers and underline the common factors. So we've got 4. So something times something will equal 4. The obvious one, and I'll get you to do this every single time, it's going to be 1 times itself. 1 times itself. So the factors of 4 would be 1 and 4. That would be correct. However, is there more? Remember, if there's only just 2 numbers, then that would make it a prime number. And the only even prime number is 2, because 2 times 1 is 2. There's no other factors, no other, you can't do something else times something else equals 2. So any even number has to be a composite number. Alright, find the factors for each set of numbers and underline the common factors. Don't worry about that part. All I want, just list all the factors. 1, 4, the other one would be something times something, it's 2. Ideally, we'd like to put them in sequential order, so smallest to biggest. But you could do this, work it out first, and then you can put change it around if you like. Nice and neatly though. 2, 4. If I just jump over, maybe one over here, do one more. Factors of 20. So this is, again, always put the first one, the obvious one. Something times something gives you 20. The obvious one would be 1. And the other one, probably at the end, would be 20. Because 1 times 20 would give you that. When you're looking for factors of a number, it has to be smaller. Because otherwise, you might be getting confused with multiples. So, factors of this, something else. Can you think of something else times something else gives me 20? Well, it's an even number, so it must be divided, be able to be divisible by 2. 2 times what would be? 2 times 10. Okay, and I know there's 2 more factors that fit into that. That would be 4 times 5. So there are 1, 2, 3, 4, 5, 6 factors that fit into 20. From here, we won't go into it, but for those people who want to go the extra step, you could then sort of look at doing a factor tree. We've got 20 up here. Now you can use any of these factors in these pairs, but you don't use 1. That means you can't use 20. So I could use 2 and 10, or 4 and 5. So I'll show you what that looks like. If I put a 2 times 10, this is the part where I go, okay, is it a prime number? If it's a prime number, I circle it. And that's the end of my sort of branch. It's a prime number, I can't break that down any further. This one, 10. Are there any factors that fit into 10? Yes. That would be, and again, yes, 1 times 10, but we don't want any 1s in this tree diagram. So I put 2 and 5. I try and break this down as far as I possibly can into its lowest prime number. 2 is a prime number, and 5 is a prime number. And that's my tree diagram. However, if I want to go the extra step, so that's sort of step 1, step 2, step 3, I would then put this 20, I can do this. 20 is basically, how many 2's do I have here? It's 2, and how many 5's? 1. So I could do 2, I could do 2 times 2 times 5. 2 times 2 is 4, 4 times 5 is 20. I can do it the other way. 5 times 2 is 10, it's 20. Or if you want to go the one final extra step, you could do it. This is the next level. How many 2's are there? 2. And I'll put the little 2 up here. This is my exponent. How many base numbers are there? 2. 1, 2. Multiplied by 5. That's saying 2 squared. 2 times 2, or 2 times itself. And so that's where we're going. So when you do this, have a go at these ones on Monday and Tuesday.